Good afternoon, everyone. I'm just going to allow 1 or 2 minutes for everyone to join. Okay, good afternoon, everyone. I'm Daniel Goldsmith. I'm a quantum computing technologist at Digital Catapult. It's an absolute pleasure to be here this afternoon to welcome you to our second quantum webinar. And today we're going to explore how your business can get started with quantum computing. But before we do that, I'd just like to start with a little bit of housekeeping. So first of all, we'd like to remind you that this webinar is recorded and will be available on our YouTube channel probably over the weekend or early next week. So during the webinar, you'll have a chance to ask questions ready for the question and answer. So if you have any questions at any time, please submit these into the Q&A box at the bottom of your screens throughout the webinar. Please note, however, that we've disabled the chat box, so if you need to contact us urgently, please use the Q&A box for that. So I'm going to start off by giving a short introduction to Digital Catapult. So Digital Catapult is the UK authority on advanced digital technology, and our mission is to accelerate industry adoption of these advanced digital technologies in the United Kingdom and leveraging these technologies to drive growth in the UK economy. And we create new opportunities through collaboration and innovation. And in terms of what we do, we specialize on 3 key areas in terms of specialized acceleration and innovation programs, and we align these to industry challenges and themes. We build testbed facilities, run pilots and proof of concepts, and test new business models. And we facilitate research and development projects, inform policy recommendations, and lead research on emerging technological trends. And we work with government and public sectors, startups and scale-ups, corporates and industry, investors, academia, and the Catapult network. And in the area of quantum, at the moment, it's quite early days for quantum computing, and we're raising business awareness of the new technology through a series of blogs, which we're writing, workshops, webinars, of course, including, of course, this one, by speaking at conferences. And we're working to understand which use cases are most appropriate for near future quantum computers. And also, we're extremely proud to be working on the Quantum Data Center of the Future project with partners Orca Computing, Riverlane, BT, KETS, PQ Shield, and academic partners. And we're very happy to have Chris from Orca here today, who's going to explain more about this project. And next year, we'll be running a technology access program, which will allow selected organizations to access the Orca quantum computer to carry out proof of concepts. And this program will include the necessary training. So if you'd like to express an interest, please email us at quantum@digicatapult.org.uk. And you don't need to write that down. We'll be putting that in an email. So we have a packed agenda today with very many talented speakers. So we're going to start off with a review of the Quantum Data Center of the Future, and we're delighted to have Dr. Chris Kazmak, Head of Product at Orca Computing, who will be running through that. And then it's an absolute pleasure to have Dr. Kiara from the National Quantum Computing Center, the NCCC, and she'll be explaining how the NCCC can help you on your quantum computing journey. And then we'll get really hands-on, and we'll have 2 sessions on running your first quantum algorithm. In the first, Kate Marshall, a developer at IBM Quantum, will explain how to use IBM Qiskit. And in the second, Francis Tibble, software engineer at Microsoft, will show the Microsoft equivalent. And then the final session will be from Dr. Diego Quinones, Innovation Lead at Innovate UK. And he'll be explaining how it may be possible to get government funding to help fund your quantum computing projects. Then there'll be a panel discussion, and I'll be handing over to my colleague, Pippa Spencer-Williams from Digital Catapult, and she'll be leading a discussion on how to break the barriers to adoption. And then we'll address all of the questions that you might have raised and entered into the Q&A box during the session. And then we'll wrap up, and we hope to be finished by 4:30. So now, without any further ado, I'd like to hand over to Dr. Chris Kazmak, Head of Product at Orca Computing. And I'd like to invite Chris to join the stage now.
Thanks, Daniel. Let me just share my presentation. Cool, that should be working. Please shout if it doesn't.
Yeah, we can see that. That looks really great, Chris. Thanks very much.
Perfect. Thank you. Yeah, thanks so much for the opportunity to talk a bit about our Quantum Data Center of the Future project. So I believe it's the largest quantum project funded by Innovate UK, both in the number of partners involved and the funding. And that's because it has a pretty ambitious goal that it tries to achieve that I'll tell you about. Let me see. So just to kind of give you a brief intro to what a data center is. So whether you access and use computational resources on the cloud directly, or whether you just use the internet, be it watch Netflix or do shopping, all that traffic, all that data is handled through data centers. So these massive server rooms that both do data storage, but also in many cases data processing. All the kind of internet traffic kind of moves through data centers. It is really the backbone of our internet. Now, that presents a few challenges naturally, right? One of them is you want this data to be secure, the data you send. If you're doing banking online or even messaging, you want your data to be secure. And there are more and more threats appearing to that security that we need to be able to handle. Just as everything is slowly moving towards the internet and moving towards the cloud, there's just the volume of data that has to be handled by data centers is also increasing exponentially. And that data often is, because it's moved to the cloud for processing, that data needs to be processed. And actually, there's a huge environmental footprint to processing that data. In fact, training a kind of state-of-the-art AI model in the cloud currently has a bigger CO2 production than the lifetime of a car or even a person's lifetime, and definitely more than a flight. So it's really important to try to make data centers more energy efficient. And finally, there are things that we are not even anticipating in terms of data center usage. I mean, there are new applications popping up all the time, including, for example, driverless cars. Like, that's a huge processing task that to some extent can be done locally in the car, but probably in a big proportion will be also moved towards the cloud and have to be handled by data centers. So to kind of solve these challenges, there's a lot of work being done on data center hardware and software. So very different new types of processing chips are being developed to handle all this data that is going through data and being processed in data centers, from very general purpose chips like CPUs that traditionally were the workhorse of computing, to more specialized processors like GPUs that are gaining prominence in data centers for AI applications, or TPUs being invented by some of the big companies to handle very specific workloads, up to very specific chips. And so there's a lot of development being done on improving the hardware for this, and many different types of chips and technologies. But actually something that is very exciting and why we're here is quantum computing. So that is potentially a new form of computing technology that can really solve some of these problems in energy efficient data processing. Now, these quantum computers exist already, small scale, but you can run them, and I'm sure some of the other speakers will tell you more about all the cool stuff you can do with them currently. And they're very impressive pieces of technology, like the one shown here on the picture. But it's really hard to imagine them currently kind of sitting alongside your GPUs, your CPUs, all the kind of server data racks that I've shown on the first picture, illustrating a modern data center. So while there has been a lot of now interest in kind of making these technologies integrate well with classical processing, there hasn't been a dedicated program yet to put them in a data center. And that's really the subject of this project. The goal of this project is to integrate quantum technologies of two different kind of flavors into a modern classical data center, and that is quantum computing technologies. And here is, where Orca's expertise in building full stack photonic quantum computing systems comes into play. The reason we like photonic quantum computing for data centers is photonics works at room temperature in ambient conditions. It doesn't require very complex, cryogenic or vacuum infrastructure to run. So it really can be fit in a rack potentially and operate in the same conditions as kind of classical computing technologies. So we as Orca developed these kind of 19-inch rack size quantum computing systems and the software to control them. But then the other aspect that I mentioned, talking about the challenges of data centers, is the security aspect. So one of the use cases for quantum computing is actually breaking current classical encryption. And so if you want your data to be secure for long periods of time and be secure for the advent of quantum computing, you need to implement kind of quantum safe security in your data center. And this is the other part of the project, is developing that quantum secure, quantum proof security for modern data centers. And, again, like these systems exist, but they need to be really miniaturized to be able to be scaled up to the level that is required for modern data centers. So really, we are taking in this project a very practical approach to integrated quantum in data centers. We're not looking at how do we build a new type of data center around quantum technologies. No, but we're looking at how do we take quantum technologies and make them fit a modern classical data center so that they can be incorporated. And there's so many layers to that, from the hardware layer to the software layers, the orchestrators, figuring out, how a problem should be split between the GPUs, the different types of classical processing units and the quantum processing units. How do you communicate information between different nodes? All this is something we want to tackle in this project, which is why it's quite ambitious and requires so many great partners. And then finally, once we develop the quantum computers that are scalable and can form the actual workhorse of computing, not just support classical computing, but really take on the role of most computers themselves, we will want to be able to network them together. And that's where these ideas of a quantum internet come in. And so a kind of third pillar of this project is designing a blueprint for the quantum internet, figuring out, like, once we build all these great technologies with quantum security, quantum key distribution, quantum computing, how do we merge them together to really form a networked quantum computer, quantum internet? So to solve these huge challenges, we've assembled a superstar team of partners, both from large corporates that can provide use cases such as BP, to companies that do own and know a lot about data centers, such as British Telecom, BT, to all the quantum SMEs that are developing this new type of technology, from Ketz Quantum on the security side to Orca Computing on the computing side, to the best academics to really figure out the outstanding research and scientific challenges to be able to miniaturize and scale up these types of technologies. And we have University of Bath, Imperial College London, UCL, working with us, and University of Bristol. And finally, we have Digital Catapult as well, acting on behalf of the end users who will use this technology once it becomes available. And so really, the one takeaway from this presentation would be to understand that we're really taking this very practical approach. So this is not just a research project to develop new cool technology. It's really to develop useful technology today. So the whole project is centered around these demonstrations of technologies in the natural data center environment. So every year we have a demo day where we invite our customer advisory board that represents the users and the data center owners to see where the technology has progressed, where it's now, what are the plans, so that they can start thinking ahead of how do we incorporate these quantum technologies into our infrastructure. And so while during the project, we'll be looking at just developing the technologies and kind of capturing the requirements, showing it, testing it, and demonstrating it in real environments and developing a community around these technologies. The idea is to go further post-project. So then really look at select practical applications with customers that might come from the customer advisory board or might, get interested in this project through its lifetime, and really show value with these small systems running in kind of experimental data centers. But then finally, once we validated that the technology works and is scalable, then of course we want to go to the hyperscalers, the massive data center owners, and get our systems there, both on the security side and the computing side, so that they become available on the cloud to a much larger volume of users. And with that, I'd like to thank you very much for your attention.
Chris, thanks so much. That was really excellent, brilliant. So just to remind you that anyone watching this video can potentially get involved through the Technology Access Program. So you'll have an opportunity to receive training on this quantum data center, and then potentially to run your own applications actually on the data center to gain experience of quantum computing. So now I'd like to invite to the stage our next speaker. It gives me immense pleasure to invite Dr. Kiara from the National Quantum Computing Center. So Kiara has very kindly agreed to talk about the National Quantum Computing Center, the NQCC itself, and then to explain how they can help you on your quantum journey. So Kiara, your slides look great. I'll hand over to you. Thank you very much.
Great. Thank you so much, Daniel. And it's really great to be with all of you today. Thanks, Daniel and Pippa, for inviting me to this workshop. So in the next 10 minutes or so, I just want to tell you a bit about the NQCC, as Daniel said, and tell you how can the NQCC help you and users in your quantum readiness journey. And of course, I'm Kiara. I'm the Quantum Innovation Sector Lead at the NQCC. So for those of you that are not yet familiar with us, the NQCC is a brand new national lab, which was launched in September 2020 with 93 million over 5 years of investment from UK Research and Innovation. We are building a brand new facility at the Harwell campus, which is due to be completed in mid-2023. And today we're about 30 employees, although when I joined just about a year and a half ago, we were just 6 of us. The purpose of the NQCC is really to enable the translation of UK research strengths into innovation. And our vision is for the UK to harness the potential of quantum computing, having addressed some of the key scaling challenges of this technology. We have 3 overarching large objectives. The first one is really building and evaluating prototypes, and I'll tell you about this in a moment. We build partnerships, so we really work across the entire quantum ecosystem with profiles within the research community, industry, business, government, and the public sector. And we do all of this to be able to deliver a long-term roadmap for quantum computing adoption in the UK. And so here on the bottom of the slide, you see a few more granular objectives within these three major ones. So we want to be a body that provides assurance. We want to catalyze the supplies base, accelerate scaling, provide the development focus for quantum computing, drive the user adoption, and support skills and training. So the NQCC's program revolves around 3 key strands. The first one is technology. And so as I said, we are building quantum computers at the NQCC, and we basically design, build, operate, and host these quantum computers. We are focusing primarily on superconducting qubits and trapped ions platforms at the moment, but we stay very, very open-minded to any alternative platforms that are emerging. And we do this development through both having teams at the NQCC that work on the platforms, but also through procurement. The second strand is around the facility. As I said, we are building a new center, and the center is very much built with collaboration in mind. So it's built to be able to host double the amount of the NQCC staff, so that we can invite collaborators from all the different stakeholders we engage with to come and work with us at the center. And finally, we have the engagement strand, which is also a very important one for the NQCC, and it's all about creating a user community for quantum computing in the UK. And I'll mainly focus on this strand in the next slides. But as a summary, we are a national center who is working on developing quantum computers based on a variety of different platforms. And so we really want to be able to provide assurance and a neutrality towards the different platforms. And we're also unique in the sense that we not only focus on the technology development, but we're also very, very much working in close contact with end users. And so we stand a little bit at the center of the quantum computing ecosystem, and we act as an anchor organization. And so there are lots of different stakeholders that we interact with, ranging from industry and users in a wide variety of sectors, but also the technology developers and the academic research community, government, and other national labs. And our role is very much to be able to support, to enable this technology and to link between all these different stakeholders. So I mentioned the engagement strand, and quantum readiness has been a topic that has been on our minds over the last year very, very much. What do we mean by quantum readiness? So this is really all the activities that organizations may undertake to be able to become quantum ready, and so to be fully prepared to harness the potential of quantum computing. And so we do believe that early adopters and the end users that start engaging early with the technology will gain advantage as they can develop their expertise in time. But we do think that this is a very challenging journey, and it goes through a variety of different phases, starting out from awareness raising, so understanding what is the technology, what is the potential for your organization, through to engagement, so maybe undertaking some small proof of concept projects, evaluating whether the technology is for you mature enough at this point or not yet, and then action, and finally advocacy. And so in order to deliver and to really create a mechanism to support end users through this journey, we worked on a very specific program called Spark, which I'll introduce in the next slide. But before that, I wanted to give you a bit of a sense of the history of Spark and the backstage, how we came to develop this program. And so we did this very, very much in close contact with end users. We started with selected bilateral conversations, and I've spotted a couple of end users we engage regularly with in the audience. So this was very much to understand their drivers, their key needs, and their barriers. We then brought all these end users together in a workshop and roundtable to gain more insight. And we finally launched the program Spark in May of this year at the Harwell campus. And so you see some of our articles that we've put out throughout this development. And so what were these needs and barriers that we kept hearing over and over again from the end users? So they wanted help with identifying and developing use cases. They wanted help with access to quantum computers. They wanted help with creating internal business cases, help with developing algorithms, help with benchmarking the current hardware and software solutions, and help with upskilling and training. And so we took this feedback on board, and we tried to create a program that kind of addressed all of these needs. And this is Spark. Spark is our user engagement program, specifically targeted to end users who may be individuals or organizations. These end users may be within the industry sector, but also within the research community. And it's very much to be able to handhold them and help them through this quantum readiness journey. Spark has three key objectives. The first one is to help with discovery and development of use cases and applications. The second is to enhance quantum computing literacy and upskilling. And the third is really to create a user community for quantum computing through networking events and ideas sharing. And so we have four key pillars within Spark. The first is as the NQCC, we act a little bit as a broker, and we provide access to quantum computing resources, eventually our own resources, but in the interim also external parties' resources. The second pillar is that we provide collaborative R&D support and applications expertise. So we have applications engineers within the NQCC that can work hand in hand with end users. The third is workshops, hackathons, networking events. And the fourth is learning resources and skills development. And so I just want to give you a couple of case studies within each one of these pillars and tell you what we've been up to in the last year and give you maybe some ideas for potential collaborations. In terms of access to quantum computing resources, we've put a memorandum of understanding in place with Oxford Quantum Circuits, and they are very much the first partner that delivers quantum access for us on behalf of the NQCC. And we are in discussions with a number of other providers that we'll bring on stream next year. In terms of collaborative R&D, we've just closed our first call specifically for projects around use case development. So this was within the STFC cross-cluster call. These projects are 3 months in length, feasibility studies that are really studied to be able to support end users in their first exploratory projects. So really to understand the potential of quantum computing for them and the requirements of the use cases that might have. These projects will be running from January to March of next year, so very soon. And we're hoping to run further calls along those lines next year. So please get in touch if you have an interest, or keep in touch with the NQCC through the LinkedIn page and the website to stay up to date. In terms of workshops, hackathons, networking, lots has happened. We've run our first hackathon in the summer, and we're very, very happy to have an engagement event, which was very much Spark in miniature. So we had end users, we had quantum computing providers, we had hackers, which were master's, PhD, and postdoc students in quantum computing. And the outputs of that were fantastic, and you can read about this event on our website. I also wanted to flag other activities, for example, a specific activity that we've been leading throughout the last 1 year with the financial services sector. So this was very much a sector-based activity where we convene different representatives of the financial services sector in the UK, and we try to understand the priority areas for them, for the banks to work together to deliver solutions that are of benefit of the entire sector. And finally, learning resources and skills development. We've worked with the University of Bristol to put together 2 online courses. One is specifically focused on quantum information theory, and one is on quantum computation. They both run their first course this year, and I've just received the dates for next year's round. So the quantum information theory course will run from April to June of 2023. So if you have an interest, do get in touch with us, or Google the University of Bristol Quantum Computing online course. We may be able to support some of the end users in gaining access to the platform through the NQCC. The second thing we've done is we've commissioned an online skills course, very interactive, self-paced, specifically targeted to professionals that might not have a very strong math or physics background. And this course will become available from early next year. And so these are my final slides. So we've engaged with a big variety of stakeholders over the last year, not only end users that you see on the left-hand side, but also regulators, quantum providers, the government, and various universities, organizations. And we really look forward to expanding our engagement further. So if you have an idea, you're not sure how to get started with quantum computing, feel free to get in touch with us. We're very open and very happy to have conversations and see how we can work together. And so with that, thank you so much for your attention. Of course, feel free to visit the NQCC website and to reach out to either me or Jeff, who's our business development manager.
Kiara, great. Thank you so much. That was really interesting. And if you're wondering how to get in touch with Kiara and her colleagues at the NQCC, we'll be sending out an email after this, and we'll put contact details there. So now we're going to move on, and so far we've had talks about things, but our next presenter's not just going to tell you, she's going to show you. And it gives me enormous pleasure to welcome to the stage Kate Marshall from IBM, who's going to actually give a demonstration of actually really logging on, or maybe it'll be recording, really logging on and using a quantum computer in Anchor. So Kate, whenever you're ready, if you want to start presenting your screen, and then you have the stage.
Perfect. Thank you so much. I'm just going to talk for a couple of minutes and then I'll start sharing my screen. As you mentioned, thanks so much for the introduction, Daniel. I've made a recording of my demo today because too often have I been demoing and the demo gods have not been on my side and things haven't loaded or something. So just to ensure that we actually get something useful out of the next 10 minutes, I have recorded something in advance. So guaranteed success this way. But yes, hello everyone. I'm delighted to join you today from IBM Quantum, where today we'll be looking at how to compose your first circuit towards building your first quantum algorithm using Qiskit. So circuits, which themselves are made out of quantum gates, are basically the key building blocks towards implementing quantum algorithms. So it's really important that you first get your hands dirty with quantum circuits, and then in the first instance, and then furthermore, as you work with quantum circuits, you'll begin to see that every quantum program or algorithm can be represented or implemented using a series of quantum circuits, and in some cases, a combination of classical and quantum circuits as well. So what is Qiskit? First of all, you might be asking. It is an open source software development kit that's based in Python, working at the level of circuits, algorithms, and application modules to program quantum computers. If you're familiar with Python, some of the code we'll be looking at today might make more sense to you, but if not, not to worry at all. Python is a fairly readable language, but also it's not necessarily really to have any Python prerequisite knowledge before you get started with Qiskit, our software development kit. So please don't worry if you don't come from a programming background. So our SDK essentially enables everyone with internet access to log on to our platform and begin programming quantum computers from the comfort of their own home. So quite literally from their laptop, which is where I recorded this demo earlier. So we'll show you how to log in and how to actually go end to end with an example. But one point I would really like everyone to take home today is that it's actually really easy to get started with programming quantum computers over the cloud and using these different software development kits. And it's what myself and the speakers after me will really try to show you today, is that it's very easy to log on and start working with quantum. So with Qiskit, in only a couple lines of code, you can begin to access several different quantum systems, ranging from superconducting qubits to trapped ion qubits. It's not specific to IBM quantum hardware. Qiskit actually already works with various different providers, various different hardware stacks. And if you're in a rush and you don't want to queue your jobs so that they're all running on real devices, then of course you can also run your jobs on a simulator to emulate the behavior of a quantum system as well. By using Qiskit, you'd be joining a global community of tens of thousands of users that are all working to push the boundaries of quantum research and development. So a really exciting and welcoming space to be. And if you're just getting started versus if you've got some experience with this hardware, there's something out there for you when working with Qiskit. So I'll begin sharing my screen now. Please shout if you can't see it. Should be sharing it now. So for example, the Qiskit textbook that you can see here, it has a really, really wealthy a range of different resources for getting started. You can start to learn about the principles of quantum computing here. And there's also more advanced different walkthroughs of different algorithms and some lab exercises as well. So it's a really, really comprehensive resource for learning. We'll be working with Jupyter notebooks on the IBM Quantum platform today, which is an interactive notebook environment, which makes it much easier for writing Python code without having to install any prerequisite packages and things to make it work. However, I do recommend, if you'd like to continue using these tools in the future, that you look up some of the tutorials and things to get both Jupyter and Python and Qiskit installed on your laptop locally, and I can share some of those with you after if you're interested. So as I mentioned, I have recorded a video, so let's see how this goes. Basically, we will be working today with a tutorial that you can see at the top. It's called Code Your First Quantum Circuit. I'll share this later with you, of course. In this tutorial, you can see an explanation here of working with the user interface that we'll be working with, and also an overview of how to get started with circuits towards building your first quantum algorithms. We'll be working with the IBM Quantum platform today. So we'll go to quantumcomputing.ibm.com, where you'll see a screen like this, and we'll first log in with an IBM ID. You can create one for free online. It's very quick and easy. You'll then land on a page that looks a lot like this, where you can access two different types of resources, either the IBM Quantum Lab, which brings up a Jupyter notebook environment, or the IBM Quantum Composer, We're going to start with the IBM Quantum Lab today for interacting with your Jupyter Notebook, but we can also have a look at the composer later if time permits. I'll need 1 minute for that. So I'll open up my lab environment literally at the click of a button. And yeah, cue elevator music here, but it's generally quite fast. And then once you land, you'll see that there are a set of default imports when you click on one of these notebook options here, which basically helps you to get started as quickly as possible. So it's going to import all the packages that you need by default. We are actually going to start from scratch and copy and paste over these imports in the first instance, just because we want a couple more packages than is automatically populated here. So we first import all of the packages needed to run the very short circuit. And then back on the tutorial page, you can also see the instructions there to copy and paste the actual build a circuit script there. So we'll walk through at a very high level what's going on in this circuit. So what we're doing here is actually, in fact, I'm just going to let this play a little bit further so you can see there is an explanation there should you want to go through this a little bit more slowly after the session, for example. But as part of this circuit, we're basically creating a circuit with 2 quantum and 2 classical bits, all initialized to state 0. And we're going to apply essentially 2 of the most common quantum gates to this circuit. One of them is a Hadamard gate, which puts the qubit that it's associated with in a state of superposition. And then we're going to be applying a CNOT gate, which essentially applies this, essentially physically entangles this quantum bit that's now in a state of superposition with its associated neighbor. So I'm not going to have time to go into what those terms mean, but if you're interested, of course, I'm sure any of the panelists would be happy to walk you through those in more detail later. But the main end goal here is to create something called the Bell state, which is a very simple or friendly experiment to show that how measuring a quantum bit in a state of superposition is a probabilistic experiment, because when you measure the Bell state, there's a 50% chance of the qubits basically both assuming the value 0 and a 50% chance of both qubits assuming the value of 1. So a good demonstration of the probabilistic nature of measuring a qubit in a state of superposition dependent on the options that were basically generated at the time when you measured. So we're creating this very, very common state as part of this circuit here. We're going to create this Bell state, and you can see here in this description the different bits that I've just talked through, and it also shows you here what the action of the Hadamard gate and CNOT gate does, as well as the measurement action there as well. So you can go through this tutorial a little bit more slowly if you want to after this session. So once we've copied this code over, we can actually execute the experiment. And in this example, we'll be executing on a simulator. And when we execute this cell here, which you can do just by clicking that run button there, you'll see the results at the bottom, which is essentially a perfect distribution of 50% of the results were in 0, 0, and almost 50% of the results were, or slightly more than 50% of the results in this case, were in the state 1, 1 as well. So in the execute explanation here, you can see that we've actually run our experiment on a simulator in this example, but you could also run it on real quantum hardware. You would just have to wait a little bit more or a little bit longer for your results, because as you can imagine, the real devices are slightly more popular. Once we've done that, we can also see that we've, as is common with quantum experiments, sampled our experiment 1,024 times over, which we can see here. And then in order to visualize our results, we can actually plot them as a histogram, which is what we'll do in this next step here. And we can also draw the circuit so we can visualize it as well. So I'll just let that cell paste there. And we can see there the histogram of our results and the visual of our circuit. So it really is easy as that, which is, I remember the first time I saw this, I thought, gosh, I didn't know it was so easy to get involved with programming quantum computers. But you can also use the composer tool, should you prefer a more visual learning platform. So here, if you just navigate to here, you'll see there's also a composer tool, and you can actually compose the same circuit here. So you can replicate exactly what we did in that tutorial by dragging and dropping these gates. And you'll be able to see the same sort of 50-50 probability if I was to measure each of those qubits. And that's everything we wanted to walk through today on this platform. I think I'm handing you back to Daniel now, who will move on to the next speaker.
Kate, thanks so much. That was really brilliant. A totally flawless demo. Excellent. Yeah, I really enjoyed that. I'm actually a Quiskit
pre-recording.
I'm a Quiskit fan myself, and it's a wonderful tool. So now it gives me a lot of pleasure to hand over to Francis Tibble, who's from Microsoft. And Francis is going to give a demonstration, I think, of maybe the equivalent to Microsoft tools. So we can see you. Do you have anything you'd like to share, Francis?
Yes, I will share my screen.
The stage is yours when you're ready to start sharing.
Thank you. Can you see that?
That looks perfect. Thanks very much.
Thank you. Yeah, so I'm taking a similar approach to Kate. My demo has been pre-run, so as long as my screen doesn't refresh, it should be good. But yeah, I'm Francis Tibble. I'm a software engineer in the Microsoft Quantum team, and today I want to take you through a tool that we've been using internally for quite some time, and recently we made it public. And so this tool is the Azure Quantum Resource Estimator. So what I've got here, if you're not familiar with Azure Quantum, it's our platform for cloud computing. So you can access lots of different types of quantum hardware. You can run your programs on simulators, and as of last month, also a resource estimator. So what I'm sharing here is a quantum workspace that I've got set up. And similar to what Kate was showing, we have a notebook kind of view where you can run different samples without having to install anything. So I'm just going to make this bigger. And basically, the point that I'm going to start from here is, imagine you've got a program which, similar to the previous demo, you might have run on a simulator, and then you might have wanted to go and run it on some hardware and found that the program you've got is perhaps maybe requiring too many resources than the current hardware can offer today. And so one of the things that you might want to do is understand what are the requirements for your program, and you can do that using a resource estimator. So this particular demo isn't doing anything special in terms of the program side. What I'm going to just scroll to is this bit of Q# code, which if I had thought about this more intelligently, I would have shown a Qiskit sample, but we do have a Qiskit sample as well. And this uses, this is just an operation which does a very simple multiplication of two numbers. So nothing particularly impressive. But what we're going to do is run that against the resource estimator and look at the types of requirements it would have. So if I scroll to the cell which actually executes it against the resource estimator, again, I've got no waiting time because I've already pre-run this. But if we go to the result, what we can see is a summary of the different things that we get back. So one of these is physical qubits. So for this particular, the default settings for the resource estimator, when running this program, you can see that that very simple multiplication program needs 173,592 physical qubits, which is a lot. The runtime, not so scary, but that's 3 milliseconds. And if we were to go through all of these different drop downs, there's a bunch of different other pieces of information that you can get out about the requirements of this particular program. And so the one that I'm actually going to focus a bit on now is the physical qubit parameters. So the nice thing about the resource estimator is that it's customizable. So in the default parameters that I ran with it just then, it was using a qubit gate NSE3 parameter setting, which is basically a description of the qubit parameters that were predefined. So whether you've got you know, a superconducting device, a photonic quantum computer, an ion trap quantum computer, each of those you can describe the different qubit parameters in a way that you could run this resource estimator. So I'm just going to scroll down, and just to put a bit of put more detail to that, these are things like the gate error rate, the gate times, the measurement error rates, the measurement times, and these might not mean anything to you, which is perfectly fine, which is why we have a number of predefined qubit parameters. So these vary based on whether the instruction set is gate-based, or whether it's a Majorana instruction set. And this is important for me as a Microsoft person, because the type of quantum computer that we're building is a Majorana instruction set. So I'll actually be, we ran with this one as the default, and I'm actually going to be running using this one in just a moment. So that's the qubit parameters that you can change. One of the other things that you can also change, if I scroll a bit further, is quantum error correction settings. So basically, when you think about the hardware as it is, a physical qubit will have some inherent noise, and really what you'll need is multiple noisy physical qubits to create a logical qubit that you'll be able to use to do some computation. And in order to get that useful logical qubit, we have quantum error correction schemes. And one of the most famous ones is the surface code, which you can use for both gate-based and Majorana-based instruction sets. And that was what I was running the original demo with. The next one that I'm actually going to run is the FlowK code, which is something that some very smart people in our team at Microsoft Quantum have developed. And this is, at the moment, it's specifically for Majorana instruction set. And so kind of the grand reveal is then if I run that same program using these qubit parameters, the Majorana settings, if I use a quantum error correction scheme that is the FlowK code, and then run that again, what we'll see here is the physical qubits are now 26,208 as an estimate, and the runtime is now 547 microseconds as an estimate, which I think this is about 40 times less, and I think this was maybe 6 times faster, if I've got the numbers right, again, as an estimate. And so the really useful thing with this tool, and something that our team has done in developing software applications, is that you can go ahead and start writing software today. You can run it using different parameter settings based on what devices you'd like to experiment with as like future fault-tolerant quantum computers. And you can start getting estimates for what resources those programs would need. And so in the cases for our team internally, we'd run this for one particular application, and the runtime, even with like a good machine, an optimistic machine, it was still going to be taking like thousands of years as a runtime. So what that told us was really we needed to go ahead and like redesign that software and think about the software more smartly so that we could bring down the runtime, which we were able to do by optimizing the code and using tools like the resource estimator. So I think that runtime came down to maybe a few days, which is achievable. So yeah, I'm out of time. That's all I had to demo today. So I'll pass the control back over to Daniel.
Francis, thanks very much. That was really interesting. I can imagine that's a really useful tool to find out what's needed to run quantum algorithms. Thank you very much. That's really appreciated. So now we're maybe going to change gears slightly, and we're going to have a presentation on a different topic. And I'd like to invite Diego Quinones to the stage. Diego works for Innovate UK, and he's going to explain to us how we can get, or how you potentially might be able to get government funding for your quantum computer projects. So Diego, the stage is yours. Do you have something would you like to share?
Yes, I'm going to be sharing my screen now.
that was perfect. Thank you very much, Diego.
Okay, so I will start. So first of all, thank you so much for having me here. It's a pleasure and honor to be with all of these speakers. So as mentioned, I'm Diego Quinones. I'm Innovation Leads at Innovate UK. And I will be talking about different funding that we provide, in this case, to quantum computing, and one funding opportunity that will be coming up from us. So first, you might not be aware or you might not be familiar about UKRI. So UKRI stands for UK Research Innovation, is an agency that invests government funding into research and innovation. And this is by partnering with academia and industry. All the funding is distributed through the 9 leading councils that you can see here. So among them, there is Innovate UK, which I am part of. Innovate UK is the national agency for innovation in the UK. We support businesses-led activities, projects, and into all sectors of technology in the UK. And our objective is to help businesses to grow through the commercialization of new products, processes, and services, and support this development by different activities that we develop. So as part of Innovate, we have the Commercializing Quantum Technology Challenge, which I'm part of. We in the Commercializing Quantum Technology Challenge have allocated 174 million pounds in different projects, which has been matched by almost 400 million pounds of match funding in industry. And these projects are aimed to develop new products and services based on quantum technologies. So in our portfolio, we have 139 projects which involve 141 companies across different sectors of industry, including automotive, healthcare, infrastructure, communications, security, and so on. So talk about quantum computing specifically. So far we have allocated 30 million in funding for projects related to quantum computing, which has been matched by 21 million pounds from industry. From these projects, the involved companies, 12 of them, have managed to raise 54 million of investment, which talk about the importance of getting funding from Innovate. And by doing so, they were able to lead 18 quantum computing projects. This is the current portfolio, and we are expecting to add some new projects that haven't gone live. So you might see these numbers going up in the next couple of weeks. So now talking about funding opportunities, which is probably what you are more interested about. We have an upcoming competition, which is feasibility studies in quantum computing. So we are working in partnership with the NCCC to deliver 8 million pounds in projects, which should be aiming to apply innovation solutions to industry problems using quantum computing, and possibly explore the impact and feasibility of such applications. We aim to bring together end users from our industry, so the different types of applications possible, along with experts in quantum computing to identify use cases that will show the potential commercial benefits of quantum computing. So just some important information about this competition. The eligibility, first, each project can receive up to £500,000 in funding, should be able to start by September of next year and end no later than end of February of 2025. It should involve one or more end users, because this is focused on applications. And as all of our projects should be able to carry its work and intended to exploit the results within the UK. Some important dates. We are going to be announcing this competition in December. So if you currently go to our website, you are not be able to see it because we haven't announced it. And then at the beginning of next year, we're going to have a couple, at least one cultivation events, which will give you more information. It will help to bring together different partners to discuss the possibility of different projects. On February is when the competition opens, and it closes in March. And so just be mindful that because we haven't announced it, we haven't put in any specific dates. So please be looking into our different website and social medias from Innovate UK to see the announcement. But if you have any question or you would like to receive more information, please do contact us at the email that we have here. So that's it for me. Thank you so much.
Diego, thanks so much, and we really appreciate you giving us like an early visibility of these exciting announcements. So if you are thinking of getting funding for a quantum computing project, obviously well worth like looking at the Innovate UK website and social media in the coming months. So now we're going to do something different. We're going to have a panel, which my colleague Pippa Spencer-Williams from Digital Catapult is going to host. So Pippa's come online, and Pippa will shortly be joined by Francis, Kate, Kiara, and Chris. And the topic of the panel is breaking through the barriers to adoption. And just to remind you, if you do have any questions either about anything that you've seen so far or anything that occurs to you during the panel, do type them into the Q&A section at the bottom of the screen. We'll be very interested to hear from you. So now I'm going to hand over to Pippa, who's going to lead the panel. Thank you very much, Pippa.
Thanks, Daniel. Yes, good afternoon, everyone. I'm Pippa Spencer-Williams, an innovation partner at Digital Catapult, and I'm delighted to be joined by our panelists, Kiara, Francis, Chris, and Kate. So we're going to launch into it, and as Daniel says, if you do have any questions for any of our panelists or on anything you've heard, then please do drop it into the Q&A and we'll pick them up at the end of this panel session. So without further ado, I'm going to start with Chris. So you spoke about the data center of the future at the start of the session, Chris. I'm wondering if you could share maybe what type of individual from an organization could be a good fit for a program like Quantum Data Center of the Future?
Yeah, so I think any really. So both from maybe technical members of the team. You know, we have a lot of technical expertise within the consortium, both on the security and computing side of things. So it could be people involved in managing a data center, network engineers, all of them we'd be happy to speak to and could benefit from this project, up to also managers. And, you know, we also speak business language. So definitely we welcome them to engage as well on how you can use these types of quantum data centers. I will say though, on the maybe just to comment on the kind of technical side, very often with quantum computing, it's natural to think that a physics background is helpful, and it is in many cases helpful, especially a quantum background. But sometimes it can also come with a lot of biases towards a certain technology or platform or approach. So it's quite just useful to just keep an open mind. It's not clear yet, you know, which approach will give the most value the soonest. So yeah, I would just recommend having an open mind and just, you know, seeing what quantum technologies can help you with.
Thanks, Chris. Yeah, that's really good to know that sort of the quantum programs are open to everyone. And I think in terms of the technology access part of that program, I think as Chris mentioned, you don't necessarily need a physics background. And as Daniel shared a little bit about, there will be training opportunities as part of that. So definitely open to all. Kiara, I'm just wondering your thoughts on that as well in terms of the opportunities that the NCCC are offering at the moment.
Yeah, sure. So I guess we have a bit of a wider variety of resources. So depending on which pillars, if you remember the 4 boxes of Spark we're talking about. In terms of the collaborative R&D, the use case development, this is obviously targeted to end users. And now this can be an organization that doesn't have a quantum team at all, and that really wants to start understanding the potential of quantum computing. So one of the best mechanisms would be to apply for one of these feasibility projects where we can provide the applications expertise and the organization can provide the use case. And so similar to this, but a bit scaled down, would be an activity like a hackathon. So the hackathon is a really useful activity specifically for those end users that don't quite have yet a good understanding of quantum computing, but they do have a feeling that one use case they have might have potential to be solved with quantum computing. And so what we've seen in our hackathon is that many of the end users this was their very first experience with quantum computing. They just had the hunch that their problem was interesting, and so they just came, provided the use case, and within 2 days, a team of quantum computing experts had developed the first steps towards solving the problem and then delivered a report to them. And so I think that's the best way to really kickstart your journey and just to start having a sense of the potential of quantum computing for your organization. In terms of upskilling, we have a few different resources, and the idea there is to be able to address both people within an end user organization that might already have a physics math background, but not so much quantum computing, deep quantum computing understanding. And so, for example, the courses with the University of Bristol are perfect for that individual because they go quite in depth. They're online courses with assignments with lots of maths, and so that at the end of them you really have a solid understanding of processes in quantum computing and quantum information theory. If on the other hand you have people in your team that maybe come from an IT background or an engineering background or whatever finance background, they've never been exposed to physics, for example. The online course that we're putting together, the interactive one, is the better resource there because it really goes from basic concepts through to intermediate and advanced in a very interactive way, very visual, with lots of simulations. And this way we aim at basically enabling those people to actually understand the basics of quantum computing and become practitioners themselves in time. So yeah, a variety is the answer.
Fantastic. Thanks, Kiara. And I think, as you say, these programs that are around at the moment and the opportunity is really, really important for organizations to be able to at least tap in and start to see the opportunities that quantum can bring. So thank you both. I'm going to move on. So to Kate next. Kate, there's a lot of hype around quantum computing at the moment. We see it in the media about the importance of it. But I'd like to really understand from your perspective what companies can realistically get out of programs and projects at this moment in time.
Yeah, really good question. I think the hype around quantum computing is something to be very cautious of. I guess it's somewhat normal for every innovative technology to see that, but perhaps it's a bit more so prevalent with quantum because there is this intrinsic exclusivity around the fact that the theoretical principles are so difficult to comprehend that it makes people feel, I guess, quite a lot more excited when they're reading about it. But yeah, I guess it makes it more hype prone. It's important to emphasize, and I know this has been mentioned in previous of the digital catapult seminars, that quantum isn't going to solve every problem that we find classically difficult to solve today. They're very specific types of problems, so simulation, machine learning, and optimization problems, for example. But as much as we mentioned that we're still some time away from seeing any quantum advantage in these spaces, there's actually lots to be excited about today. For example, like we've mentioned career paths a few times, the potential new career paths for young people looking to find their niche in such a competitive tech industry. There's a whole new world of possibilities opened when it comes to quantum computing. different problem mappings, so trying to understand the industry to industry impact of quantum computing from company to company. This could take years, so definitely something we can be doing today before the hardware really hits that era that we call quantum advantage. And furthermore, I guess maybe personal opinion, but I think the results that we're seeing from the noisy intermediate scale quantum era is actually really exciting, and it's sometimes overshadowed by the fact that we're still waiting for this era of quantum advantage. But loads of the experiments that companies are running who are really invested in this research and development stage, they're starting to see some really exciting and promising results from even using these noisy machines. And finally, I think it was Chris that mentioned earlier, mentioned very briefly sort of quantum safe. Well, the opportunities available for protecting data for a post-quantum landscape, these are very new offerings, and they're actually available to take action with now. So it's an incredibly important issue for lots of companies, but something that we can actually make moves today to prepare ourselves for. So that's also quite exciting too.
Great, thanks, Kate. Frances, do you have any thoughts on that as well?
I guess probably echoing similar feelings. I think I completely agree. Sometimes quantum is seen as this very advanced topic that a lot of times can prevent people from even getting started, and that definitely shouldn't be the case. There's so many resources out there for people to get started, to try and bring down that barrier for what is sometimes quite overwhelming, a lot of the physics ideas in quantum computing. I know it was something that when I started, I was like, wow, I definitely don't understand this. But yeah, being able to take the things that you do know, whether if you're coming from a programming background and then getting started with the things you're familiar with and programming, whether you do have the physics background, you do have the chemistry background, and getting started with things like that. So then, yeah, in terms of the hype, it probably won't go away. I guess people will carry on saying, when is the next big thing going to happen? And really, it's just being realistic about where we're at on the hardware journeys for all of the different platforms, making sure that we're reporting the progress that we're making in an accurate way that isn't overhyping the results that we're seeing and is presenting them in a way that is realistic. So I think, to be honest, as companies, we need to make sure we're doing that in the blog posts that we put out and in the discussions we have. You can't take every problem that you've got and throw it at a quantum computer and expect to see progress, because that won't be the case. But thankfully, there definitely are use cases where we do expect to see an advantage. And as Kate said, there's progress happening all the time, and we take every little bit of small progress that people are making and celebrate that. And obviously, over time, we'll get to the big achievements.
Fantastic, thanks both. And as you say, it's great to see the progress and the benefits that we are seeing to date. And I think it's important for companies to engage now to start to tap into those benefits and be ready for the future opportunities that quantum brings. So Frances, I guess staying with you for my next question, it's building a little bit onto that. So why should companies be upskilling in quantum now?
Yeah, I guess, well, going back to what I was saying, when I started my learning journey of quantum computing, this was a handful of years ago, but I have colleagues that have been in quantum computing for decades, and like, whenever there's new progress being made, it's great to have an anchor point of existing knowledge to be able to attach that to. So getting started and building up a foundation of quantum computing knowledge really then helps to be able to say, okay, this new update has come about. Now I can put it into the context of other things that have happened. In terms of businesses, I think it's especially important because, a lot of the times when you're working on quantum computing applications, it's not just happening in isolation. Like, we've seen a lot of cases where you might be taking a problem that, in the case of optimization applications in particular, might have thought, okay, we're working on this innovative area. We've reached a point where we don't think we can see any more progress with optimization techniques that are available now. Is this something that we could see a benefit with by using quantum computing. And the idea of starting looking into that right now is really important, because those things don't just happen overnight. You need to build up business cases, you need to be able to get funding to work on these projects, you need to be able to take the time to get the subject matter expertise around those problems from different parts of the business, to then be able to spend the time building up a proof of concept for quantum computers, and being able to understand, will you even see progress using a quantum computer, and what kinds of hopefully advantages you might expect to see. So yeah, it definitely makes sense to start now. Those things definitely take time. So there's real value in doing that today.
Absolutely. Thanks, Francis. And as you say, it's part of the journey. Kiara, have you got any thoughts on that you'd like to share?
Well, I think Francis did a perfect job. I don't have that much to add, but I would say that, yeah, I mean, I agree that upskilling is very important, and there are obviously different levels depending on the resources that organizations have. So some maybe smaller companies don't have that much resource to put towards upskilling or creating teams. And to those, my recommendation would be to try to create a network of experts that you can tap into without necessarily having it within your organization. So maybe this is a network including some academics or academic partners. And I think that the reason why this is important is that obviously within your journeys, you will have to create what Francis says, your business cases internally to justify putting resources towards quantum computing. And I think it would be very important to be able to justify which platform you want to engage with, or which types of SDK or softwares you want to use. And for that, you need to really have critical thinking within your organization. You need to be able to a bit cut through the hype, obviously. And that's a challenge that we do hear from end users, that is just very complex in this field, which is constantly evolving, to keep track of all the developments, to keep to basically divide what's hype and what's the reality, and to be able to navigate basically through all the resources that are out there.
Fantastic. Thanks, Kiara, and thanks, Francis. Chris, I'm coming over to you next for our next question. So what advice would you give companies who are just starting out on their quantum journey today?
Yeah, I think this will be similar to what Kiara...
Oh, sorry, we couldn't hear you, but we can now. So if you just start again.
Yeah, no, I was just going to say, I think Kiara already mentioned it, finding the right partners on this journey. It is there's a lot of material to learn quantum basics, as Francis and Kate showed, but applying it to specific use cases is often quite difficult and requires a lot more education and upskilling to be done in companies. So I guess the best first step is to look at these kind of trustworthy partners. And these can be institutions like the NCCC, for example, but also companies like Orca. So we have a lot of experience working with customers who both are experienced in quantum or just dipping their toes into it, to kind of help them figure out what quantum is useful for, but also what is not useful for. And that answer is often useful as well, to kind of, as has been mentioned before, kind of get away from the hype. So yeah, finding the right partners is probably the first step.
Yeah, really, really important. Thanks, Chris. Kate, any thoughts you'd like to add to that one?
Yeah, no, trying to think of something that Kristen mentioned there. That was a really good answer. I mean, I think for me, it's super important to get hands-on with the software and talent training in the industry that Francis and Kiara were mentioning. The hardware game is on, as it were, and like, to be honest, regardless of what sort of technology prevails in this industry, the software stacks are likely to remain pretty stable. As we do have the materials available to us today to actually strategically position ourselves to be able to use whatever hardware becomes available. So I would say that the key one for me would be start upskilling our workforces and using the software. As mentioned earlier, that it's almost advantageous to not come from a physics background when you're doing that. Like, we'd like to see computer science and other business trained minds having a look at this technology, looking at it critically from an industry perspective as to where the biggest findings for benefits to real people could be found, and basically building really, really scalable technical stacks that physicists might not be the best people building for. So yeah, we really need computer scientists and people using the software to really get to grips with this technology so we can take advantage of it as soon as it's ready for us.
Fantastic. Thanks, Kate. Some really insightful comments. We've got a few questions in the chat, so I'm going to move over to that. So for anyone who is online, if you do have any questions, please drop them into the Q&A and we'll cover them off with the panelists. So my first question is, we have a next generation disaggregated multi-cloud digital information storage orchestration platform. It is a purely classical compute algorithm that provides a quantum resistant alternative to conventional encryption. We believe it could be a key enabler that supports interoperation between the classic and quantum worlds. Would we qualify for funding within the frameworks that have been discussed today? Ooh, so I don't know if whether we need Diego on. So Diego, are you still on the line? Are you able to answer that?
Yeah, so what I understand, this is kind of like post-quantum cryptography, which I don't believe that enters in the scope, but what we published this is still not set completely. So if you look to the actual competition announcement, you will get a better idea, but so far I would say might not be in the scope.
Okay, thanks, Diego. So next question, what advice are you providing to establishments in setting themselves up to engage on quantum? So both in terms of resources, training and skills. Do they go guerrilla, e.g. a few people dipping their toes, or more structured, for example, setting up a team with a full review of technical options partners provided? Which of these approaches has so far been seen by the team to provide the best outcomes for establishments? Kiara, do you want to maybe comment?
Yeah, sure. So we've very much seen the full spectrum, I would say, at least with the end users that we've been engaging with. So some of them have completely gone gorillas, like you, right? So some really put resources up front, and they create a specialized team, and within this team they already, maybe have run a couple of projects, proof of concepts mainly, and this obviously helps. Once you start to run use cases projects, then you extract information, and that helps you to build those business cases. There are other organizations that are a little more cautious and that are taking a bit of a slower journey. So they may just dip their toes in, look at the resources out there, and keep a watching brief on the technology until the technology is more mature. So I would say this really a bit depends on the resources that you have internally in your organization, as well as whether the type of use cases that your organization has are what type of use cases you have. So there are certain sectors which we see are already more mature with their engagement with quantum computing. For instance, I mentioned the financial services, and we've started an activity with that sector because they were way more mature than other sectors. I would say other sector, for example, pharmaceuticals or health tech, they are very much engaging, but they're also in a very, very pre-competitive stage still. So then, yeah, basically it really depends on you. And my advice would be to reach out to organizations such as the NCCs, Digital Catapult, companies such as Orca, and try to let them help you in figuring out where you lie on this spectrum and what are the correct mechanisms for you to start engaging with the resources that you have. Yeah.
Fantastic. Thanks, Kiara. So we have no further questions in the Q&A at the moment, so I'll just open it up to any final comments or points from our panelists. Chris, anything further you'd like to add to what we've discussed so far?
No, I think this was a great session. I would just reiterate, if you are interested on getting on this quantum journey, contact us. Digital Catapult, NCCs, these are all very good organizations to get a start on that.
Great, thanks, Chris. Kate, any final comments you'd like to add?
No, I don't think so from me, but yeah, really, really pleased to have joined today, and thanks so much for all the really engaged questions.
Great, Kate. Francis, anything from you?
Likewise, grateful to be here. Thank you for listening.
And Kiara, anything final you'd like to add?
Yeah, thank you so much for listening and being so engaged. And I would say this technology is extremely exciting. So in the next few years, we'll really be able to see lots and lots of development. So we're very happy to share this journey with all of you.
Fantastic. So I'll now hand back to Daniel for sort of closing comments. Thanks, everyone.
So thanks very much for all our panelists. I'm sure that you'll agree that it's a really interesting and insightful session. If you missed our first webinar, it's actually on YouTube. You can find it in the Digital Catapult YouTube channel. If you'd like to get in touch with any of our speakers, if you have any follow-up questions for us or for our speakers, you can reach us at, it's actually on the screen now, quantum@digicatapult.org.uk. And finally, it's very important for us to understand how these webinars went. When you finish this webinar, you'll get a form to fill in. So if you could ask you just to take a couple of minutes to complete the form. It's only got 5 questions, and give us your feedback. And also we'll be sending out an email with a slightly more detailed survey where we'd like to find out the sort of topics that you'd be interested in hearing about in the future. So if you could fill that in, we'd really appreciate that as well. So thank you again. Thanks to the marvelous panelists. It's been a total pleasure listening to you all speak. And thank you very much. I think we're going to end the webinar now. Goodbye.